All right. So another interesting application of this is something like this. So let's say we want to find the area bounded by these two graphs here. Now, drawing this by hand, we could do by, picking a few x values, plugging them in, and trying to connect the dots. But we have Mathematica at our disposal, so why not use that? Right? So I went ahead and plotted these here, and we're going to end up with something like this. Now, if we look here, we have a region here. So there's two regions that are bounded by this. We have this upper region here, or this left region here, and this right region here. Over here, there's nothing bounded, and over here, there's nothing bounded. So we're really looking at the area of these two little humps here. Now, one interesting thing to point out here is, notice that what function's on top changes when we go from one hump to the other one. So in order to compute this area, we actually do have to split it into two separate pieces. So we have to find out all three of these intersection points, and we know it looks like sort of -2 to 0 is going to be the blue on top, which is the cubic function, which is our f of x. Right? And from 0 to 2, it looks like we have the parabola on top, g of x on top. Right? So let's verify that -2, 0, and 2 are in fact where these cross at, and then set up the area for the integral. Or, wow, I said that backwards. The integral for the area. All right. So we're going to go ahead and find where these intersect at. So same deal as last time. Set our functions equal to each other. So I have 3x cubed minus x squared minus 10x equals -x squared plus 2x. All right, so let's move everything to the left side here, and we're going to end up with 3x cubed minus 12x equals 0, right? Because these two terms will cancel. Okay, so now factor out what we can. Let's see, we can factor a 3x out of this, and that leaves us with x squared minus 4, which we can further factor as x plus 2, x minus 2, and that's going to equal 0. So what we get here is the first term tells us x is 0, second one says x is -2, third one says x is 2, as we sort of expected from the graph. All right. Now, another way you can do this, if you like, if you can pick out the x values from the graph, if you really want to verify it from that, you can just plug those three x values into both functions and verify that you get the same answer, the same output. Right? If that's the case, then you know they have to cross there. Anyway, so what we get here now is the area. We have to split this into two integrals. We get the one from -2 to 0, and remember that's the one where f was on top, so that's going to be 3x cubed minus x squared minus 10x, right? And then minus -x squared plus 2x. Okay, that's for the first integral. And then for the second integral, that one's going to be from 0 to 2. These are in the opposite order. So we have -x squared plus 2x minus 3x cubed minus 2x, minus x squared minus 10x dx. Right? So now we just need to simplify this stuff and then integrate it. So we actually know what it's going to simplify to when we combine everything together. This right here is f minus g. So this will simplify to 3x cubed minus 12x dx. And then here, right, we want to add the integral from 0 to 2. Now, if you think about it, we're really just subtracting these in the opposite order. So we're just going to get the negative of this thing here, which is going to be 12x minus 3x cubed dx. Right? Now at this point, we could of course compute this by hand, but let's leverage the power of Mathematica here and go ahead and compute this. So here we want to do integrate 3x cubed minus 12x, where x goes from -2 to 0. And plus we want to integrate the opposite of this, so 12x minus 3x cubed, where x goes from 0 to 2. Right? So integrate that, and it's going to turn out that we get 24. Right? So that's not so much of a big deal, the computation part here, but the big thing we really want to pay attention to here is that which curve is on top switches partway through. So the main thing you want to be aware of here is don't just test at one point. You really want to look at the whole graph of the situation and see, which one's always on top, or which one's on top, which one's on bottom. Does it change at any point? Because that's an important thing to keep an eye out for.